So in section 6.4, we're going to talk about the algebra functions and compositions. So this is going to hit us back on SLO number 1, demonstrating understanding and knowledge of properties of functions, which include domain, range, operations, compositions, and inverses. So we're going to be addressing that. The two module learning outcomes that we're going to be covering is perform arithmetic operations on functions and construct the composition of functions. And they'll be addressing part of that SLO. So in our workbook, we're going to turn to page 48, and we need to make a quick definition first. The intersection of two sets, denoted by the symbol of an upside down U, is the set containing all the elements that are in common both of the two sets. So you think of the intersection of two roads. They're part of the roads that the two streets have in common. So we're going to let f and g be two functions with domains d sub f and d sub g respectively. Then the notation f plus g of x means f of x plus g of x. And the domain here is going to be the intersection of the two domains of the two original functions. F minus g of x would be subtraction of the two functions. F times g of x would be you're multiplying the two functions together. And then f over g of x is f of x over g of x. Now the domain for 1, 2, and 3, when you add, subtract, or multiply two functions, the domain is going to be the intersection of the two domains of the original functions. And then when you divide, you also have to exclude the values that make the denominator 0. So that's a little bit more complicated. So let's take a look at our workbook. So we're going to turn to page 49, and we're going to do some exercises. Again, here's just kind of a quick summary of what we talked about. And then given f of x equals x squared minus 3x plus 1, g of x equals the square root of 8 minus x, and h of x equals 2 over x plus 1, evaluate the functions if possible. So first of all, for the first few, we're just kind of plugging in, just kind of getting familiar with the notation. So here we're going to plug in -3, and for x into f. You can do this on your calculator, or we can do it by hand, either way. Remember, if you want to do it on your calculator, you have to be careful how you're entering exactly how we wrote it here. Make sure you're using the minus sign down here for that -3, not the subtraction sign. And then our squared key is right here, right next to the 7 key. And then I'm going to do subtract 3, parentheses, -3, and then plus 1. See if I can get out of that glare. Hit enter, and that gives us 19. So nothing really new there, just kind of reviewing a little bit how to work with function notation. So let's try number 2. So we'll have the square root of 8 minus, and we're plugging in 4. 8 minus 4 is 4. Square root of 4, that would be 2. So let me circle these answers. Now number 3, this is a little bit trickier because we're now plugging in an expression. So again, I'm going to write this out. And then I'm going to plug in this a plus 1. And we've seen this before. We have to be very careful here with this a plus 1 squared. I need to go through and FOIL that out. So I'm just going to write it up here. So I'm going to FOIL. A times a is a squared. a times 1 is 1a. 1 times a is 1a. 1a plus 1a is going to give me a 2a. Just combining like terms. And then 1 times 1 would be 1. So we'll get a squared plus 2a plus 1. So be extra careful on that one. So that's what we get for this part. For this one, I'm going to need to distribute that -3 to both terms. Those are supposed to be arrows. Minus 3a minus 3. And then bring down the plus 1. And now I'm just going to combine like terms. So I've got my a squared. 2a minus 3a is negative a. And then 1 minus 3 is -2 plus 1 is -1. So really these first 4 problems are just kind of a review of what we did in chapter 5. All right, let's try number 4, g of 10. And so we're taking the square root of 8 minus, plugging in 10. That's going to give us the square root of -2. And that's undefined in the real numbers. In fact, if I try doing that on my calculator here, second square root, if I type that in, I'm going to get a domain error. We'll see in the next unit that we're going to rewrite this in terms of I square root 2, which will allow us to continue working with the problem. But for now, anytime you try to take an even root of a negative number, it's just going to be undefined because we're just playing in the real numbers. All right, so finally, we're now ready to apply the notation f over g of -8. That means f of -8 over g of -8. All right, so I'm going to go into my f function. I'm going to plug in -8. And then on my bottom here, I'm going to do my g function. Go grab that real quickly up here. I'm just grabbing them from up here. And now I need to simplify each of these. So again, if I want to, I can use my calculator. So I'm going to first do the numerator. So in the numerator, parentheses -8 squared, subtract 3 parentheses -8 plus 1. That's 89. And now let's do the denominator. And again, if I want to put that whole thing in, I can. I'm going to be using my square root key here, so I'm going to do my second x squared key. 8 subtract -8. And that will give us 4. And really can't simplify that, so we'll call that our answer. Made my fraction bar a little bit too big. Okay, let's try this next one. Now notice here, I don't have a number. I just have x. So this just means g of x subtract f of x. So I'm going to write down what g of x is. That's the square root of 8 minus x. Subtract f of x is this x squared minus 3x plus 1. Now, there's not much I can do here. About the best I can do is distribute that negative. Now, just a little note on the domain here. If my function f, I've looked back up here, my domain here was all real numbers. For g, this thing here is only defined when 8 minus x is greater than or equal to 0. If I go ahead and add x to both sides, 8's got to be greater than or equal to x, which is the same thing as saying x has got to be less than or equal to 8. So my domain here for this one would be negative infinity to 8. When I'm doing this, I have to see where these overlap. They overlap on this second interval. So my domain, even though this part's defined for all real numbers, I have to look at the whole thing. So this would have a domain of, whoops, my bad there, negative infinity to 8. This one's kind of frustrating, so we don't have a value for x, so we really can't take this any further. They'd have to put a number here. Let's try number 7. So this means g of 0 times h of 0. So I look at my g function. And I'm going to multiply that answer with my h function. So I'm plugging in 0. Looking at this first one, that's just the square root of 8. Looking at the second one, that would be, well, that's going to work out to be 2. And we can rewrite that as 2 square root of 8. Now, we do need to simplify that. So on your calculator, if I take 2 square root of 8, and this works on a TI 30XS. If you have a different calculator, then you'll have to do this by hand. If I enter it, will simplify it for me. Rewrite that as 4 square root of 2. So that's the exact answer. And a lot of times Alex will want the exact answer, so you just leave in that form. Now, if they say you approximate to 3 decimal places, then on your TI 30XX, you can hit this double X key and it'll give you an approximation. So my approximation here would be 5.657 if we round that to 3 places. So you just have to pay attention to the directions in Alex. Let's try number 8. Here we've got g of negative 1 plus h of negative 1. So this would be equal to the square root of 8 minus negative 1 plus 2 over negative 1 plus 1. Now in that first one, that's just the square root of 9. But this one we get, my bad on that one, plus 2 over 0. That's undefined. It doesn't matter if the square root of 9 is 3. If this is undefined, the whole thing is undefined. So we would say this is undefined. We can't do it. Cannot divide by 0. And let's try this last one. So again, we're not given a value for x, so we're just going to write down the function and subtraction, and then we write down h of x, 2 over x plus 1. And that's really as far as we can get it. In terms of our domain, the domain of g was this here. X cannot be equal to -1, so I have to remove -1 from here. So that's going to split this into two intervals. So if I need to state the domain here, that would be from -infinity to -1, parentheses, then I'd put my union symbol, -1 to 8, including 8. Oh, sorry about that. So let's try that again. So I'm taking out the -1, it breaks it right here, so it'd be from -infinity to -1, parentheses, union, parentheses, -1 to 8.